How's the audio? Okay, nothing? No audio? Can you hear me? Can you hear me? Okay. All right. All right. So let me see if you have submitted the D2. So D2, let me see. Let me see. I have seen. Okay. So some of you submitted a demo. So I have a demo video from Christian Van Rawa, Aaron Muhammad Khaldi. Okay. Check, make sure I can see your video. So for D2, what I'm looking for is the terminal output from the Arduino TC3.5 is showing the values. Okay? So make sure that when you submit your video, your screen is big. Maximize the terminal so you can see everything. Right? You only show me the first line. I can't tell you if it's working or not working. Okay? All right. Well, don't worry about it. When you submit the videos, I always see the last one. So if you submit 10 videos, I can only see the last one. The database will tell me, hey, you have submitted multiple videos, but only let me see the last one. The first one will be somewhere in the database, which I don't know. So when did you send me an email about D2? I just checked my email. I didn't see anything. So what's wrong with D2? D2, I give you extensions for last week. The due date it's was today before class. I think the submission deadline. I don't know if the submission deadline have already passed, but you can always upload whatever you have. I think the submission deadline is no. I think the deadline is gone. It's okay. Yeah, it's whatever you have. I'll take a look. All right. So today we'll talk about D3 again to remind you about what you need to submit. Okay. So from D2, you were able to display the pixel values in 8-bit on the Arduino terminal. Okay. So we're going to take one step further. You are going to put the values into a text file. Okay. So in previous lectures, we already talked about how to create a file and write values into it. Okay. So you can write one byte at a time, or you can write multiple byte at a time. Because if you use the print or print ln, you can include the bytes, the values. Okay. So let's go over the task. You need to implement the Arduino program that will read a BMP file, 24 bits BMP from SD card, and saved, converted 8-bit BMP internally in your program. And then you are going to make sure that when you output the values, it is not upside down, it is upright. Then you are going to put the values into a two-dimensional matrix, depends on the size. For example, if the resolution of the BMP is 8 pixels horizontal, 16 pixels vertical, then the 2D matrix is going to be 8 by 16. The values in the matrix will be put into a text file, for example, demo3 d3demo.txt, and then in there, the values will be presented as a two-dimensional matrix, and the syntax will follow. It's a C program syntax. Okay? All right. So the matrix will be initialized with the values that you extracted from the file. The file can handle up to 320 and 240. So you need to submit your code before the class starts, and the demonstration will be live. So this is additional work that we're going to do for D3 and beyond, is that you do not pre-record your video. When the class starts, I'll give you the file. Then you do a demonstration live, record the videos, and submit it during the class time. So this way, I'll make sure that you can do the work live. Okay? And submit your source code, submit your videos. So video, source code, send view. So what's the output look like? So I wrote the program and I used the D1 sample. So I read the D1 sample, extract the pixel values, make sure that it is not upside down, that it is upright, and then output the values in hexadecimal. So this is a C syntax two-dimensional array with initial values. So you can see that each value is a hexadecimal value, 0x left to right, and there are 16 columns and 24 rows. Now, based off our previous lecture, we know E0 means red, 1C means green, and CO3 means blue. And this is exactly the picture we used to develop the program for D1. Okay, so a small picture, it's good for you to do development and debugging of program. Make sure that your program works with the smaller picture, but your program shouldn't be hard coded to work with only small pictures. you can go up to 320 and 240 pixels. Understand? Any questions about what you need to deliver for D3? Okay, no question? All right, let's continue. So if you recall, D1 is to extract BMP pixel width plus BMP pixel height. That's what we do. D2, extract BMP pixel data plus 24-bit to 8-bit conversion. Okay? Plus terminal display. So for D3, we have extract BMP pixel data plus 24-bit to 8-bit conversion plus output to txt file 2D matrix. So what's D4? D4 is going to be one step further from D3. So we'll be doing everything D3 can do plus VGA display of 2D matrix. So from D3, you have a file, a txt file, which contains the two-dimensional matrix that represent the pixel of your image. So now we're going to take that file, the content of the file, and then copy and paste into the code you developed for NEOS 2. And then you're going to use that to display the image. So in this case, you do not hard coding anything in NEOS 2 C program. You just copy and paste the content of the two-dimensional matrix into NEOS program, and then use your NEOS program to display the content of the two-dimensional matrix and put it on the VG screen. So during this time, you don't have to know what's in the matrix. Your job is to display the content in the matrix. So the code that you develop for NEOS 2 is very simple. Is to display pixel by pixel on VGA using a nested loop. So in last class, we talked about nested loop. Okay. So in this case, is horizontal plus vertical. So you look at your C program in Neo School, it's going to be very short. So since all of you have taken ENGN3055, please look at your own work that's associated with ENGN. You can use that and then develop the program for this. So in this case, again, no hard coding for anything. You only need to know this is the matrix I want to display, and these are the values. Where do I get the values? I get it from my Arduino program, extracted from the BMP file. Understand? Once you make this whole flow work, displaying data or image on the screen, it's automated, or as I'll say, semi-automated, because each program that you create from the Arduino, you can extract any image into a file. Okay, if you can handle 16 by 24, you can handle 160 by 240. You can handle 320 by 240. You know you know that because your program works. Then you just copy and paste the data into your C program, and then there you go. You can see everything on the screen. Okay? Of course, I'll give you more meaningful demo files. It's not just a blank or block of blue and red. All right. So let's see who's in here today. We have Aaron, Van, Mahama Agandi, JC, Rawa, Manny, Christian, William, Muhammad Kali. Is Monica here? Is Monica here, please? Is Monica here? No? Okay. Okay. All right. So that's enough about this sample. We're done with this. Enough about this. So today we'll talk about D5. D5, we're going to change the gear a little bit. Instead of writing programs, you need to write a research paper. All right. So first, the research paper is very short. It's only 4 pages, not including title page. Okay? Not including the reference. Reference does not count toward the content. So what is it about? It's about open source licenses. What is open source? What is a license? Okay. First, a license is something that you can create to get rewards for your work. Okay. This is very common in the industry. For example, if you create a song, you can't just say channel in the broadcast. Okay. So for example, if today I start to play a background music, and then I need to make sure that that music is not licensed attached. Because if somebody found out I use a background music with a license attached, I need to pay them the fee, whatever the fee is. Fortunately, I don't have that. So a license means the developer, the creator, can collect rewards, fees, or a lot of time we call this royalty. Okay? Since we're in the engineering field, many times you invent something, you don't just go ahead and apply for a patent. Most of the time you apply, you own the work you create, and you want to get compensated for it. Okay? So in other words, it's in general compensation. But the different types of license. The first type is you cannot use my work unless I give the license. So I'll give you one example. Intel developed microprocessors for PCs and that. Right? So Intel owns the design. Intel knows how to start the machine, how to work with hard drive, how to work with your CPU and GPU. But AMD also does it, right? So how can you guarantee the work AMD created will work with Intel machines? Of course, you buy different motherboards, but you don't buy different hard drives. You buy different CPUs, but you don't buy different memories, right? So how do they make sure that they work? Is that when you install Windows, Windows doesn't really tell you, hey, because you're using AMD, I'm going to give you a downgrade version. I'll give you the full version of Windows. But the Windows work with Intel. The Windows also work with AMD. But what does it? How does it work in the background? That the Windows know that okay, the Intel works, the AMD works, even though they're from two different companies, they still work. Well, the truth is, Intel give a license to AMD such that AMD can produce products to compete with them. You say, isn't that stupid? Why do I need to do that? I want to own the market. Well, in this country, you don't do that. That's called monopoly. You cannot be monopoly in the industry. Understand? Okay. So Intel provide license to AMD such that the AMD can manufacture and design their CPU to be compatible with Intel. Okay? All right. So in that case, Intel can make a product. AMD can make a product to compete with them. Intel cannot go and sue them. Hey, you copy my work because they don't copy. Intel doesn't give them the design. Intel give them the license to do this. Okay? Similarly, when you use your cell phones, there are many cell phones on the market. But bottom line is the cell phone market always have a CPU. And the CPU, most of them, it's based on the the ARM processor. Okay? So there's only one company making the ARM processor, but there are 10 different or 20 different or even 100 different vendors and using the ARM processor to make cell phones. Then you ask, are they just copying each other? Well, in some sense they do, because they need to get the license from ARM to design and manufacture the processor to be used in the cell phone. So in this case, ARM collects fees from these vendors. So Samsung licensed through ARM, Apple licensed through ARM, Qualcomm licensed through ARM. Okay, so they all get a license from ARM, saying, "Okay, I can use your processor design and make my own version and make it a processor for the cell phone." So ARM in turn gets a reward, gets a license fee. Not only that, when Samsung sells one cell phone, because there's one processor in it. They need to get a royalty payment to ARM. So ARM not only get the license fee by allowing the Samsung, Apple, Qualcomm to use their design, they also get a cut, okay, from the sales. So we ask, hey, what's the big deal, right? Well, the big deal is if you sell one cell phone, it's a small amount of money. However, when you sell billions of these, the lump sum is quite significant. So in general, each year they can collect at least a few $1 billion from all these vendors as a royalty, and maybe a few hundred millions as the license fee. Okay, so it's a good business. So this type of licensing scheme is completely for profit. You can't get profit from it. Your business is based on this. Okay, so your whole business is I'm going to create designs people can use, and then I'm going to collect fees and royalties. That's my compensation. That's my reward. All right. Next, there's the opposite. Open source license. What is this? This is a new, I shouldn't say new, this is an ongoing development in the industry where I will give you everything about my design. For example, I want to make a D10 light. So we all have used a D10 light. I'll give you the schematic of my D10 light. I'll tell you which components are put in where. I'll tell you the physical dimension of the board. I also give you the printed circuit board design, the PCB files that you can manufacture. Okay, so if you have enough capital, you can take that design and then reproduce the D10 light on your own. So this is called open source design. Okay, now so far, any questions? So far, any question about this talk? So no question? All right, let me continue. So open source design. Now, open source design doesn't mean that you can just go ahead and steal somebody's work and then go ahead and do it. The open source design always have a license attached. Okay, so the creator give you the right to use the work as is and to do something. Okay? So in terms of license, you can get licenses that will be commercial purpose or non-commercial. So commercial purpose means that you take somebody's design, you're going to make profit from it, you're going to make products and sell it. Okay? Non-commercial is, oh, I'm just hobby. This is my hobby. I want to make the thing myself and then use it for my own. I'm not going to make millions of these and start selling on the market. Understand? So I give you one example. The Teensy 3.5. So the the manufacturer give you the schematic. If you go to the website, you can see the schematic. You can see how everything is connected, all the components you're using. However, you cannot produce the board. Why? You don't have to design for the printed circuit board. If you want to go ahead and create your own version of Teensy 3.5, what you need to do is you will take the design schematics, okay, then create your own printed circuit board using, for example, the Eagle software that I asked you to learn on your own to make the circuit board. Then you can fabricate a printed circuit board, buy all the components that you need, and then solder them down onto the board. You can do that. However, it is not easy because making a printed circuit board as complicated as a TC 3.5, it is not. It is not that easy. And also, there are some components on the TC 3.5. You can only get it from the TC 3.5 manufacturer. You cannot get it on anywhere else because those are not for sale. Because those are their own product. Okay? So if you own anything that's exclusive to you, we call this intellectual property, okay? Or in short, IP. So for example, the TC 3.5, the manufacturer, the owner created this intellectual property, these components that can only be purchased from them. You can go to any vendors other than TC vendors to get these components. And this is the intellectual property. So they can get fees or they can get compensation for this. So every time you want to make a TC, you get a component from them. Okay? And then you can use that components to make a product, TC 3.5 clone. Okay? So in that case, the license attached to it is not open source because they didn't open up everything. They only give you partial files like the schematic. And then your job is to figure out how to do this on your own. Okay? So this is not an open source. um, the D10 Lite is not open source because if you look at the menu, they give you a schematic, but it doesn't give you any file for you to use to create a printed circuit board. So you have no idea how to do it. And also, you don't even know the dimension of the board. It doesn't give you that. You need to figure it out on your own. And those dimensions are not breadboard friendly. So those dimensions are all weird dimensions. Weird dimensions. Because they get corners, they get holes you need to take care of. Okay? So coming back to the open source design. So what is open source? Arduino is open source. You can go to Arduino website, you can download the schematic, the printed circuit board file, and then you can manufacture Arduino. However, there's a catch. There's a license attached to it. The license says if you want to make a product based on the Arduino open source product, you also have to make your product open source. Understand? You say, wait a minute, this is a catch. Yes, you get things for free, then you need to make your things free or open source to the public. Okay? So when you have an open source product, you better follow the license. Otherwise, people can go after you for Arduino. Okay? So the license attached to the Arduino is that Arduino is open source. You make your product based on Arduino, then you have to make it open source. Okay? Now this is not only applied to the hardware, like the printed circuit board or your bread or your circuit. It also applies to the software, meaning that if you make a library to Arduino, Arduino is open source. You use the open source information to make a library, then your library must be open source. Do you get it? So this is hardware plus software. Well, then you may ask, what's the big deal here? Now, why are people doing this? Well, the reason you're doing this is to build up a ecosystem or community. People contribute into this community. Okay? So people start looking at this carefully and say, well, if I start with free stuff, I end up with free stuff. So can we make changes? Yes. There are different varieties or different types of open source license or design. Okay? So they create variants of this open source. Some of them says you can use my stuff completely free of charge, free of rewards, free of loyalty, free of compensation. Some of them say, well, you can only use this for non-commercial purpose. Some will say, well, you can use my product as is. You cannot make changes. And there's one flavor saying, You can make my products, you can use my product, but you can make changes, but you need to give me credit for the original work that I did. Okay, so your job for the research paper is to research on the internet for different open source licenses. There are more than four. There are many, many more. I only ask you to do four because four is a good number. Your job is to research four different open source licenses and then write about them. So I give you some areas you should cover. Again, this is not a Q&A. This is the area you should cover. Which license is R completely free of royalty, license fee, patent fee, or no patent infringement? Okay? Which license is free of restrictions for commercial product? Meaning that you get this open source files, but you cannot make any changes to it. You cannot make commercial product out of it. Okay? So for example, you take the Arduino case, you get the files from the Arduino.cc. Well, you get all the library, the software, the PCB files. You change the color of the board from blue to red, or to green, or to yellow, or to purple. Then you sell it as a new platform. The Arduino lets you do that because that's the intention. But some license will tell you, yeah, you can use my file as is. You can change not even the color of the board. So if I give you as green, you gotta show me as green. If I give you blue, you better be blue. If you change the color, you get into trouble. But Arduino lets you change the color. That's why on the market you can see there's so many Arduino colors. You get the black, the green, the red, the purple, the blue. I haven't seen any yellow or any pink yet. Okay. All right. Which license give you a commercial product created complete ownership? So this is another catch. Is that yeah, you use the open source files that I give you, and then you create your own file. That's your own products. Doesn't mean that I own a piece of your work. Well, some license say yes, some license say no. The creator of the new product takes 100% ownership. Okay, all right. Next, there are licenses for crowdfunding. And now you know that there are crowdfunding websites nowadays. For example, Indiegogo, Kickstarter, Crowd Supply. They have a new way of defining these licenses, meaning that okay, now I'm going to have a campaign on this crowdfunding website. I want to create a laptop, so I'm asking you to contribute $1,000 each person. And if you like my idea, pitch in 1,000. So you get your $1,000 worth of laptop. However, you do not own my laptop. I can make commercial products again using this cloud funded money, but you do not own any part of this because the license restrictions. You contribute for the initial work, but you do not own any piece of the company or any piece of the work. Okay? Some licenses is restricted as domestic only. Some of them is international. Some of them is there's no boundary. You can go to Mars and still make this product. In some of them, it's suitable for engineering disciplines. Some of them is suitable for music industry. For example, song-wise, you create a song, but people start copying it. But it's very hard to tell what they copying 100% or 50%. But there are rules they have they can apply to determine whether to copy it. And some licenses have very special condition. For example, there's a time limit. So I'm going to put this license restriction only for 3 years. Okay, why? Because in 3 years, this product probably is obsolete. So, for example, if you look at the first generation Arduino, that was like 20 years ago. Nobody was using it because it was so bad. So even though they have a license to restrict anything, it doesn't really work anymore because nobody will use them. And people will use the newer generations. And the newer generations have a different license scheme. It's more open source. Okay? So these are the questions that will facilitate your writing. And this do not use it as a Q&A. It's not like question number one, do this. Number question two, do this. Do this, do this. No, it's not. And this is the individual assignment. So these are the points awarded to you for this. And this is the outcome assessment assignment. Initially, this assignment is 1 week. But since right now we're going online, I give you 1 more week to finish it. The due date for this will be 2 weeks. Okay, so D5, 2 weeks. Okay? So let's look at the due date. This is due. This week is the due date for D3. Next week is D4. Okay? Then after is D5. Since I give you 1 more week for D5, the due date is going to be Thursday. Let's look at the calendar. It is not the 9th. It's not the 16th. It is the 30th. Right? So this week, the 9th is D3, 16th D4, and the 30th will be D5. Right? So far, any question about the research paper? I mean, again, it's only 4 pages long. Okay? Do not write more than 4 pages. If you write more than 4 pages, you get no credits. I only read the first 4 pages, not including a title or the reference page. Any question about this? D5. Okay. So this will give you a break on writing programs. Um, so once we go over this, it's D4, I will talk about D6. Okay. So D6 is about printed circuit board design. So that means you need to speed up your reading about using the software. Understand? Okay. But we won't talk about it until probably Thursday or next week. So this time, so make sure that you start writing the research paper. It's not very complicated. It's just about reading different license scheme. Okay, and then you will see that how the industry works. And sometimes you'll be very careful what kind of license you're getting in. When you find something on the internet, doesn't mean that you can use as is without any consequence. Okay? All right. Now, any question about D3? If you don't have any question, I'm going to post this notes or summary on YouLearn after your live. And then this handout for D5, it's already on YouLearn, so you can look at it. Okay. Any question about D3, D4, and D5? If you do not have any questions, you can leave the live. If you do have questions, please stay. I'll look at it with you and work with you individually. Okay? If you have trouble printing the hexadecimal, very easy. You go to arduino.cc and there it's a help and the print. So print, not stream print. There is a print. Here's the example. This is how you can print hexadecimal and decimal and binary. So this is the function you use. It's not magic. It's hard coded. Well, sorry, it's a pre-built function. So if you do this, this is how you can print. Okay, whether you print to a terminal or you print to a file, you use the same function. Okay. If you have trouble recognizing your board, there's a different story. I believe right at this point, nobody has that problem. Everybody works. Okay. All right. Anything else? Okay, I'm going to terminate the live in 1 minute. Yes, William, what's your question? Yes, you can send me your password. I can take a look. But tell me the problems you have. Okay, I'm into your computer now, William. So, uh, what do you want me to look at? What do you want me to look at? Yeah. Okay, so let's take a look. Mhm. Yeah, you need to put a wait delay here. You didn't do that. You did it. Let's wait 2 seconds. So every time you do something with the SD card, you always put a wait. You can't just do bang, 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 finish all the operations. You put a wait. Say, for example, like this. We did this in class. I don't know why you didn't type it in. No, 20, 2000. So every time you finish something, copy and paste, you wait, and you have the SD card, you wait, you have and read the buffers. Yeah, see, you have a delay here. That's good. You have another one here. That's good. But you didn't have anything before that. That's the problem. So let's verify. See, everything is working. You don't have this on your SD card. You don't have D1 sample. Well, probably you plug into a computer, but everything is working. Okay. So if you go to your computer, see. Yeah, your SD card, there's this file, but you need to put it back into TC. Then you should be able to run the program. So let's do this. Unplug the SD card from your computer, put it back into your TC 3.5, and we run this program. Let me know when you have a card plugged in. I'll rerun it. Right now, I'm working with William. So if you don't have any question, you can leave the live. Or if you have any question, let me know. I can get into your machine and help you. So please unplug the SD card from your machine and then put it into TC 3.5 and I will run the program. Then we can see the results. Alright, so I guess it's ready. So let's rerun the program. So it's saying that there's no file called D1 sample.bmp. Are you sure it is there? Are you sure the file is there? If the file is not there, then you cannot open it. Okay. I think right now the problem is not about whether you can print a terminal. The problem is your SD card. Okay. All right. So I guess William, you're all set. You can print to the terminal. If you don't have the file saved on SD card, it's not going to open it. You need to make sure that the file is there. It's D1 sample.pmp, case sensitive. Okay. Any more questions? Okay. All right. If you don't have any more questions, I'm going to terminate live in 1 minute. Okay. Take care.